In this video, we will begin going over the fundamental criteria for similar triangles. We will also see the basic proportionality theorem is going to be serving as the foundation in developing the similarity criteria. The first criterion we will be going over is the angle-angle-angle similarity condition for triangles. It says that if, under a correspondence, the three interior angles of one triangle are congruent to the corresponding interior angles of a second triangle, then the triangles are similar. For instance, if we have these two triangles, ABC and A'B'C', if we know that correspondingly, angle A is congruent to angle A prime, angle B is congruent to angle B prime, and angle C is congruent to angle C prime, then these two triangles must be similar to each other, which means on top of the congruence between the corresponding angles, the corresponding sides must be proportional. Before we look at the proof, let's also look at the following useful remark. In fact, since the interior angle sum of any triangle on the Euclidean plane is a constant, which is 180 degrees, the angle-angle-angle criterion can be reduced to the angle-angle criterion, because if there are two pairs of corresponding congruence angles in two triangles, the third pair of angles must be also congruent, since both of them are equal to 180 minus the sum of the measures of the other two angles. As we have mentioned, the basic proportionality theorem is playing a fundamental role in the development of the theory. The trick in the proof here is to fit these two triangles together. Without loss of generality, we assume AB is greater than A'B'. Under this assumption, we can find a point B double prime on the segment AB such that AB double prime is equals to A prime B prime. We can also construct an angle AB double prime C double prime congruent to the angle A prime B prime C prime, with the C double prime on the segment AC. Under these conditions, we have the angle A congruent to the angle A prime, the angle AB double prime C double prime congruent to the angle A prime B prime C prime, and the side A B double prime congruent to the side A prime B prime. Therefore, by the angle-angle sides congruence condition, we conclude that the triangle A B double prime C double prime is congruent to the triangle A prime B prime C prime. Consequently, we have AC double prime equal to A prime C prime. Meanwhile, we note that the angle A B double prime C double prime is congruent to the angle A prime B prime C prime, which is in turn congruent to the angle ABC by the hypotheses. Hence, we must have the line B double prime C double prime parallel to the line BC by the alternate interior angle theorem. Once we have B double prime, C double prime parallel to BC, we can apply the basic proportionality theorem and concludes that A B double prime over AB is equal to AC double prime over AC. However, we also have AB double prime equal to A prime B prime. So we could replace the left-hand side by A prime B prime over AB. And for the same reason, AC double prime is equal to A prime C prime. So we could replace the right-hand side by A prime C prime over AC. Hence, from the property of identities, we can have A prime B prime over AB equal to A prime C prime over AC. To complete the proof, we will employ a similar construction, but in a slightly different perspective. This time, we're going to find a point A double prime on the segment AB such that BA double prime is equals to B prime A prime. And we will construct an angle BA double prime C triple prime congruent to B prime A prime C prime with the C triple prime on the line segment BC. Under this construction, we immediately have the triangle A double prime BC triple prime congruent to the triangle A prime B prime C prime by the angle side criterion, and the line A double prime C triple prime parallel to the line AC by the alternate interior angle theorem. As a result, we have A prime B prime over AB equal to B prime C prime over BC. As a consequence, we have the ratio between A prime B prime and AB is on one hand equal to A prime C prime over AC, and on the other hand equal to B prime C prime over BC. Or in other words, the corresponding sides are proportional, which is precisely what we like to prove. And this is the angle similarity criterion for triangles. Thank you for watching, and see you next time.